So for this problem, we are given an array of integers and an integer target. We are supposed to return the indices of the two numbers that add up to a target. In the event that there are more than one solution, return any of the pairs. It is not allowed to use the same element twice. So I'll be highlighting here the important text that we have. So first, we are given an array of integers and an integer target, of course. We are supposed to return the indices, okay? This is very important, that add up to a target. So, okay, in the event that there are more than one solution, so it's possible to get more than one solution, return any of the pairs. It is not allowed to use the same element twice. So one possible question here is whether can we have an array of without any solution. So if we take a look at the example number 3, it is possible and we are supposed to return an empty array. Okay, so what is the brute force solution? The brute force solution will be to traverse the entire array. Okay, just to explain it a bit further. So here, for example, our array is 3, 5, 9, 14, 17, and 20. The target is equal to 23. So by just looking at it, we can see that the answer could be 9 and 14 or 3 and 20. So it's up to us, whichever of this we should return as a result. So for this case, its result is 2 and 3. So there can be multiple solutions. And this array is sorted, so we can also ask whether the array is sorted or not, because if it's sorted, then there will be a lot better solution than what we are going to do now. But in this case, in example number 2, the array is not sorted, so we can already assume that the array is not sorted. Alright, so let's start with the brute force solution. So the brute force solution okay, so say we are given an array of 3, let's start with a small subset, 3, 5, 9, and 8. So our target, say, is 13. 13. So we will have two cursors, one here and say one here. So the first cursor will start with the very first index, which is this, is represented by this black cursor. The green one will start on the right of that black index. So what we're going to do is sum these two. So 3 plus 5 is equal to 8. So in this case, it is not what we are expecting, so we will move our cursor to the right. So 3 plus 9 is 12. It's still not 13, so we still move it to the right. 3 plus 8 is 11. It's not yet 13. So once we've reached the end of the array, we will move this cursor to the right. So 5, and our green will start again to the index right after that. So 5 plus 9 is 14. That's not what we're looking for. So 5 plus 8 is equal to 13. So this is a brute force solution. We are traversing the array almost every single time based on the number of the elements in the array. So the time complexity for this is O of n squared. Okay? So what is an optimal solution for this problem? The optimal solution for this problem is to have a hash map or a map. Our hash map will contain a key value pair. So it's a hash map, right? So it has to have a key value pair. It will contain all the values that we have already seen. So for example, let's start with the very first index. So in this case, we will only have one cursor. So 3. When we have the value 3 and our target is 13, we need to find a complement value, which is of 3, that will add up to 13. So if we have 3, what do we need to add to 3 that will result to 13? So that will be 10, right? So 13 minus 3 is equal to 10. Okay, so do we have 10 in our hash map? No. In this case, we'll add 3 as the key in our hash map, and the index will be the value. So later on, we will see why the index will be the value. Okay, so now let's move on to the next element in the array. 5. 5. What is the complement that we need to get 13? If we have 5, it will be 8. So let's add 8. Okay, so it's not yet in the hash map, so we added it there. So index is 1. Now we have 9. 9, what is the complement that we need to get 13? We need 4. So we don't have that, so we add 9 again in our hash map. So 9, which is index 2. Oh, this should be 5. I'm sorry. Okay, so what we are adding here again is the actual value in the array. Okay, so 9. Now we move to this last item. So 8. 8, we need to get 5 in order to have a sum of 13. This 5 is in our hash map, so we know that this is the result. Okay, so the index of 5 in our hash map is 1. So this is the very first item in our solution set. And the index of 8 is 3. So 3. So this is our solution. So basically, we are just traversing the entire array once. So our time complexity is O of n, which is really good. And as for our space complexity, since we are consuming additional space, it is also O of n. So the space we require is the same number as the worst case. So it's the same number of the elements in the entire array. So it's also O of n for space complexity. Time complexity is O of n. So that's it. So let me know if you have any questions. Just comment it down below. Alright, see you again next time.